Cool. So I'm going to actually talk about some maths, which I don't usually do. So this is a pool table, and if we know the exact coordinates of all our balls, and we know the exact angle we're hitting the white ball at, and the exact force we're hitting the white ball at, we as humanity know all the maths that will tell us exactly where all our balls are going to end up on the table once everything settles down. Okay? But this doesn't actually happen in real life. We don't calculate exactly where all the balls are going to go, hit the ball. And this is why snooker players don't tend to pot all the balls on the brick. Why? It's because we don't exactly know what coordinates our balls are at. We roughly know what coordinates our balls at. We don't exactly know the angle and exactly know the force we're hitting that ball at. We know it roughly. And this is a kind of example of a chaotic system where tiny changes in these things can affect where these balls will end up. I said that's a kind of example. This is a real example of chaos where we as humanity know all the maths and all the physics which tells us where this smoke from a cigarette is going to go. But because of initial conditions, where this smoke starts, and the wind conditions, we can't predict where it's going to go. It's sort of, they all starts to flow up, and then everything sort of dissipates in the air. And this because this is a chaotic system, and chaotic systems, a nice quote to describe it is that it's when the present predicts the future, but the approximate present doesn't predict the approximate future. It's because the initial conditions of where this smoke starts, we don't know exactly, so we can't predict where it's going to end up, even though we know all the maths that will do that. So an example, a mathematical example, something called the logistic map. This is interesting because this is a really crude way of generating random numbers. And we can see we have an XY coordinate, and we feed it through these, and we'll get a new XY coordinate out. And we'll get, in a few generations, we can get some, we'll start off with all our coordinates in a circle, and in a few generations we feed it through this logistic map, and we get everything totally mixed up. Even though we know there's no randomness involved here, we know what those coordinates are, we cannot predict where it's going to end up. Another example is something called a Lorentz attractor. This set of differential equations, we can kind of think of it as there's sort of a hilly countryside, and we let a ball go, and eventually the ball will sort of settle. This one, we can see that actually the ball doesn't settle as time goes on. We see that the ball just sort of carries on going. That's just interesting. What's actually interesting is that the initial conditions of where we set our ball off is really sensitive in this. So I've set the ball off at coordinate 5, 5. If I set it off at 5.0001, 5.0001, 5.0001, it looked like it's given the same pattern, but the balls will go out to sync really, really quick. And we can see that if we plot the differences in our balls, when they start at 555 and the one slightly apart from that, we can see that the distances in each dimension start off kind of the same and then go really, really far apart. And we can see this kind of looks like our cigarette, where everything starts off the same and then dissipates really far apart. But the point I'm getting to is that chaos arises everywhere. This was a simulation project we did with an undergrad at Cardiff. We expected to get results that looked like this. There was hardly any randomness involved, so what was actually determining where these weights over time was going was not determined by randomness at all. But our simulation was giving us these really, really weird results. We were getting about 3 days off, massive, massive discrepancies, and over times where we couldn't really predict why. And the reason was because of this, because of floating point errors, which in my simulation model, the complexity of what was going on, one event was affecting another event, was affecting another event, so they all built it up to get these massive discrepancies. So just a lesson for everyone. But